Let's start by going to page 123, example number 2. Now, I realized yesterday that I was blathering on and on and on, so I didn't show you this, but it's relatively easy. Okay? So I'm reading from page 123. This is example number 2. Every student who applies to an MBA program must write the Graduate Management Admissions Test, or GMAT. Okay? It's called a standardized test. Last year, Marilyn scored 746 on her GMAT. It's not a percent. It's just a score, 746. What was that? What was it out of? I don't know.
What's MBA?
MBA is a Master's in Business Administration.
NBA?
MBA, not NBA. Not NBA.
And as soon as you said Merrill,
Yeah, you were lost. The mean was 504. Now her score was 746. Let me just jot a couple of these things down here. Marilyn got a 746. The mean was 504. So she was definitely above average. That's a good thing. The standard deviation, though, was 110. Okay, now the other fella, his name is Colin. He scored 730. Now right away you say, well, Marilyn did better, right? She got a 746, he got a 730. She did better. Well, that's not always the case, because some exams, as you know, some tests, are considered harder than others. So they factor in the hardness of the exam. So the way they do that is they look at the average. So Colin's average, his year was 515. So he got 730, but the average was 515. Was the average higher?
yes,
It was. What does that tell you about the test?
it was easier.
Possibly it was easier. But the standard deviation also comes into play as well. His standard deviation for his year was 100. Now what does that mean? It means that more people, because it's a little bit smaller than 110, it means that in his year more people were closer to the average. So in other words, who is more above average? Who is more above average in their particular year? The only way to compare these is to convert them to Z-scores. So that's what you have to do. And they show that to you right there. They want you to use Z-scores to compare. Now, I've seen the last 10 years worth of exams. You see a question on like this on the exam every couple of years. So something like this, there's a good chance could be on the exam.
Was it on last year?
I'd have to, it could have been, yeah. It could have been. I don't think it was. But that doesn't mean it won't be on this semester, right? So we're going to use our Z-score here. So our raw score in this case is my 746. My mean is 504, and I get over 110. It gives me a Z-score of 2.2. She is 2.2 standard deviations above the mean. Is that good? Is that good? That's real good. That is very good. She is 2.2 standard deviations above the mean. There's not many people that are going to be better than her, have a better score. Could we figure out what percent would have a better score than her? We could. We'd shade norm from 2.2 to 5, and it would tell us. Okay, it would be a small number. I would guess less than 3%. Devin's going to do it for me, is she? Are you shading norming for me? No? Okay. Colin, on the other hand, his Z-score is X minus mu all over sigma. His is 730 minus 515 all over 100. His Z-score, 2.15. Hey, he's pretty good too, right? But compare the two, which one's better? Marilyn is slightly better, but not a whole lot. In fact, statistically speaking, they are almost identical. Right? I mean, if you round that one up, it's the same, isn't it, right? It's pretty darn close. Okay? So when they ask you to use Z-scores to compare two things, this is what they mean. They mean convert them to Z-scores and compare. Which one's bigger, which one's smaller?
That's all you did, yeah.
All you do. No, that's not all we do.
You just said our test marks as a score.
You think I should?
Is it like a GPA?
Yeah, sort of, yeah.
Well, how did they determine GPAs?
Your GPA is basically your average, that's all.
750.
Yeah.
Like, how do you know if it's a good one? It's out of 5, right?
It's out of 4.5 now, GPAs. Used to be out of 4.
And like, how do you get up? Like, I don't know how they.
Well, you get an A in a course that counts. An A plus is a 4.0. An A is a 3.5, and so on, right? And then they just take those numbers and average them. That's all.
A plus is a 4.
Well, it's a 4.5 now. I think it's at a 4.5. Yeah.
So what if you got like a D?
That'd be like a 2.
And isn't it like, don't you need 60s to pass the levels there?
Fair enough. Okay, page 124, number 5. Page 124, number 5. Now this one is very similar to what I showed you yesterday. So Stephen, this is exactly what we did yesterday. Okay? So 124, number 5 says, the mass of the contents of a box of animal crackers is normally distributed about a mean of 210 with a standard deviation of 2.5. I would encourage you, when you're given information in a question like that, write down that number. Write down those numbers. So we've got the average for the animal crackers is 210, and the standard deviation 2.5. Right? We got a box of animal crackers. The average weight is 210. Standard deviation is 2.5. Calculate the Z-score for a box with a mass of 214. The 214 is my X. What did we call that yesterday? We called that the raw score. So 214, is it above average? The average is 210. Yeah, it's above average, right? So my Z-score should be positive or negative? Positive. So I write Z equals X minus mu all over sigma. The raw score is 214. My mu value is 210. My standard deviation is 2.5. In fact, this is going to be way above average. I don't have a calculator. I'll just use this one. Remember, when you're doing shade norm questions, you need to clear out your draw window by going second function, draw, clear draw. So you should do that. Okay, now my Z-score is 214 minus 210. I'm hoping you can do that in your head. Is it not just 4? So it's 4 divided by 2.5. Gives me a Z-score of 1.6, right?
Yes, sir.
All right. Pretty straightforward. A Z-score of 1.6 means what? A fair ways branded above average, right? A fair way average is a Z-score of 0.
Oh.
The average is 210.
Oh, there.
I would suggest you listen to yesterday's podcast, Steve. Part B says, what is the probability that the mass of a randomly selected box will be between 210 and 214? Anytime you do one of these, I'm going to insist draw the curve. Okay? If you draw the curve, even if you make a mistake, you can still show me that you understand something, and I can give you marks. Okay? So drawing the bell curve is important. So the question is, what's the probability that a mass of a randomly selected box will be between 210 and 214? So 210, 214. Right? What's the Z-score for 210? The average is 210. The Z-score for 210 is 0. What was the Z-score we worked out for 214? 1.6. So I want to find, I need to shade the region between those two Z-scores.
You go 0 and 1.6.
So you shade norm between 0 and 1.6. So second function distribution, draw, shade norm, 0, comma, 1.6.
Where's that shade norm?
Second function, distribution, draw,
Where's the distribution?
above the vars, right above, 2 buttons above the 9.
Makes sense. To the middle. I have a new pencil.
Okay, just give me 10 seconds. Okay? Well, what I do? Second function distribution, draw, shade norm between 0 and 1.6.
So we're always going to draw this.
I like it. It shows me that you get stuff. So the area is 44%.
How do you do, what do you stick your that? Your
Window?
window.
Good question.
What would you need to do that on a calculator for? If you just had 210 and 214 there, you just kind of shaded that in. It's the same.
Well, you still got to come up with that number 44%.
Where do you get that number?
That when you go shade norm, it gives it to you. That's the answer. I mean, that is the numerical answer. is that 44.5%.
So what do you see a window at?
The window is set at -5 to 5 with a scale of 1. And Y min is -0.2, not -2, -0.2 and 0.5.
And then max is 0.5. What's it scaled by?
The Y?
Yeah, 1.
0.1.
0.1. Scale for X or Y.
The Y scale is 0.1. Goes up by 0.1. So the steps for that are relatively easy. Like, what were the steps that we just did? Found the Z-score, right? Draw the picture, do the shade norm. Really, that's it. But it's knowing what to do that counts. Okay? Now, what I'm going to do here is in part C, I'm going to ask that you guys do part C right now while I just check my attendance. Did I go too fast? No. Part C says, what is the probability that the mass of a randomly selected box will be less than 214? So I want you to do C, which is less than 214, and I want you to do D, which is less than 204. Less than 214 is actually pretty easy. So I'm hoping, Luke said for C, because 214 we know is a Z-score of 1.6. So he said, do I just have to go because it's less than 214, right? So there's 214. Do I just go shade norm from -5, because remember that's the left extreme, to 1.6? Is that what you did, Luke?
Yes.
And what'd you get?
I got it right.
Which was the number what?
0.445, so 44.
4.
Wow.
0.445.
What 94.52%? Why did I write that down?
Okay, well, we got an answer of, no, you shouldn't have got 0.445. Did you?
It's like I didn't
Let's shade norm that again. I'm going to go second function distribution. Oh, hang on, I got to go back to my home screen first. Second function distribution, draw. I'm going to shade norm from -5 to 1.6.
Yeah, so I did get 0.9452. It's not right.
0.9452, yeah.
That's fine.
Yeah, right?
Yeah, no kidding. You're standing on my shoulder.
Okay, now, what's wrong? Oh, no, the picture's right, isn't it? Yeah, the picture's good. Okay, so all you really had to do was add 50%, right?
Yeah.
That's all you really had to do.
If you want to do that. That's fun.
94.5%. Okay, but D is the big one, less than 204. How do we do that? The first step is to do the Z-score. So Z equals X minus mu all over sigma. So I'm going to go 204. The average was 210. Standard deviation was 2.5. So we got to do that Z-score first of all. Let me just clear out my draw here. Second function draw, clear draw. Let me just finish this here. 204, 210. So it's 204 minus 210 divided by, what was the standard deviation? 2.5? Okay, so we get a negative Z-score, negative 2.4, right? And now we're going to go second function draw. No, second function distribution. Draw. Shade norm. We're going to go from, we're going to go all the way from 0, or all the way from the far end, right? -5, thank you. I was a little lost there. -5 to
2.4.
Minus 2.4, that's good. Now, we're just talking a little tiny bit, aren't we?
Yeah. It's
Like, you can't even see it.
I got.
You can't even see it because anything less than a 2 standard deviation is very, very below average. So it's actually like 0.8%.
So that's how many are rejected.
That's how many are rejected. That's right.
Good.
Okay, I'm just going to copy and paste here a bit so that it's in the notes. Yes, Brandon, you have a question? Oh, yeah. Yeah. Yeah, I just leave the -5, but I know what you mean. Okay, if you can do those, you're in good shape. If you can do those, you're in good shape. Now, one of the questions that they like to throw at you on exams, and this comes right out of an exam. I can't crop it, so, and you don't have this, you've never seen this question before, and you don't have it on a piece of paper. Okay? But I need to show you this because this always scares me that this is going to be on the exam, and kids aren't going to know how to do it. This always scares me. A baker randomly recorded the weights of different loaves of bread and noted the following information. For the data above, the mean is 800 grams and the standard deviation is 10. The baker thinks that the weights of the loaves of bread are normally distributed. Indicate 2 reasons that prove she is correct. Show your work using statistics. Have you seen a question like that yet? Where it says, she thinks that they're normally distributed. Prove that they are normally distributed. How the heck are we going to do that? Just because she thinks it doesn't mean that it's true. How do you prove something is normal? Okay, well, to do this, what you need to do is the 68, 95, 99% rule. Now, there is an example in the packet that I'm going to give you in a bit. There is an example of a question like this. All you do is you punch in that data. Now, it says here the mean is 800. The standard deviation is 10. Okay? So the mean is 800. The standard deviation is 10. When you have a question that asks you, is it normal? Draw the curve. Put the mean down at 800. Standard deviation is 10. So plus or minus 1, what are those numbers going to be labeled at? Plus or minus 1 standard deviation. Devin, what would that one on the left there be? 790 is right. And this one would be 810. The next set out, 2 standard deviations is going to be at 780 and 820. How am I getting those, Brett? I'm starting at 800. I'm adding on 1 standard deviation, then 2, and then the next one's going to be 830 and 770. Now the rule was, Lacey, do you remember what percent are within 1 standard deviation? I'll give you a hint. 68, very good. What percent is between 2 standard deviations? I'll give you a hint. 9, very good. Let's see if you can get a third one. It's actually 99.7. Now, for it to be normally distributed, those things have to be true. So you have to check to see if it is true. How the heck do we know if 68% are between 790 and 810? Well, look at the numbers. Look at the numbers. Okay. So how many loaves of bread are there all together? Well, there was 3 at 772, and there was 17 at that, and 44 at that, and 100 at that, and 141. How many loaves of bread are there all together? Somebody with a calculator, ladies, can you just add these numbers up for me? Because maybe that's a bit too small for you to see. I want you to add up the frequency. It's 3 plus 17 plus 44 plus 100 plus 141 plus 192 plus 191, 150, 90, 42, 14, and 9. How many loaves of bread are we talking about? 993 loaves of bread. I think this baker has too much time on her hands.
Okay.
She's weighing 993 loaves of bread. All right. So what percent are between 790 and 810? Well, 790 to 810. Are these in order? They sure are, aren't they? So this is going to be easy. So between 790 and 810, 790 would be the cutoff right there, and 810. So how many are in that range? Okay? No, you don't have the sheet. I didn't get a chance to run it off for it. So it's 7. I know you can't see. 792 to 807. Does that make sense that it's in between those? Let's go back to the start with this here, now that you guys have the sheet in front of you. Okay? The baker randomly recorded the weights of different loaves of bread and noted the following information. Do you see the weights of the loaves of bread? Do you see that they're in order from smallest to biggest? Stephen, do you see that they're the smallest and biggest? Okay, so when it asks, are they normally distributed, you have to figure out, are 68% between plus and minus 1 standard deviation?
What's our grand total?
993. The girls added them up, they got 993 loaves of bread. So how many are between 790 and 810? Well, the cutoff for 790 is 792.5 and the 807, right? So how many are there? There's 141. You got to add these up, right? 141 and 192 and 191 and 150. So how many is that?
Oh, 117.
141 plus 192 plus 191 plus 150, right? So there's 674 loaves of bread out of, how many did we say? 993? Out of 993. So we get 67.9%. What's it supposed to be? 68. Is 67.9% close enough to 68?
Yes.
I would say so.
If you round it, it is.
If you round it and sort of don't worry too much, yeah, I would say so. But that's only one. That's only one. We're still doing A. We're trying to prove that they are normal. For it to be normal, 68% have to be within plus or minus 1, but 95% have to be within plus or minus 2. How many are within plus or minus 2? Well, that's from 780 to 820. So how many more do I have to go? 780, I'll do it in blue, 780 to 820. So we're talking about another 44, 100, 90, and 42. Right? So I take my 674 and I add on a 44 and 100. And I also add on a 90 and a 42, right? 950 loaves of bread are within 2 standard deviations. Divide that by 993.
96%.
96%. Is that close enough? Most people would say, yeah, that's close enough.
Well,
Okay? So you would say something like,
what's the standard deviation?
since 68% are between plus or minus 1 standard deviation and 96% are between plus or minus 2 standard deviation, it is normal. It is considered a normal distribution. Do I have to do the third one?
No, because everything else is good.
If the third one, how much could the third one be out? Like there's only another 4%. How much could it be out? Not very much. Do we need to worry about it? No. Watch out for a question like that. Okay? That kind of question does show up on the exam. You should be able to do part B at the bottom now. I'm thinking you can do part B. It shouldn't take you more than about 90 seconds to do part B. Okay. So, what is the probability of selecting a loaf of bread that weighs more than 815 grams? What is the steps? Steve? Yeah, thanks.
Yeah.
815 grams. So the first step is to go Z equals X minus mu all over sigma. So I got 815. What was my average? 800. Standard deviation was 10. 815, that's 1.5 is my Z score. I've got more than 815, right? So I shade from 1.5 to plus 5, right?
0.0677.
Second function shade norm from 1.5 to 5.
Actually,
Now, do you need to clear the drawing all the time? If you don't, if you know what the drawing looks like, it's no big deal, because the answer is going to give it to you. It's 0.06687, or I guess that would be about 6%, wouldn't it?
yes.
Right? The shade norm is going to give you, I'm going to shade norm from 1.5 to 5, and my answer is 6.7% of loaves of bread weigh more than 815 grams. Done. Do you have 2 sheets? Did I give you 2? Or just the 1? You just have 1. I would now like you to do the normal distribution check. If you can do this, then I will feel satisfied. I will sleep well tonight knowing you know how to do this stuff.
You sleep over this.
I sometimes do. Good one, John.
Why are you putting them on?